Hello and welcome back. Today we're going to talk about the second derivative of implicit differentiation. And basically, we talked about this earlier in the year, the second derivative, when we did maxes, mins, graphing a polynomial, that kind of thing. So it's the derivative of the derivative. But with implicit differentiation, it's a little bit different. I'll get there in the course of a problem. All right, first of all, I just want to point out the notation for a second derivative is that right there, the d2y over dx squared. Pay attention to where the little 2's are. That's what it means, everything there. If you want to ask why, we can definitely have that conversation some another time. Today, I'm just teaching you how to do it. All right, so here I've got a little example. It's going to walk you through the two-step process. All right, and the two steps are find the first derivative, and then find the second one. So let's start off with the first derivative. I've got my function right there, 4x to the fifth, so that's going to be 20x to the fourth plus 3. Now that's 3y, so when you take the derivative, it's going to be dy over dx. That's the implicit part. And this equals on the other side, 11. Okay, now to find dy dx, you're just going to have to isolate that guy, just like we've done for the past couple days. And I'm going to jump ahead and just tell you dy over dx is going to equal, let's see, 11 minus 20x to the fourth all over 3. Boop, like that. Alrighty, so that's the first part. And that's what we've done already. Now we need to take the derivative of that. That's what that is. So you got d2y over dx squared. And let's see here. You see the way this is, I've got that number on the bottom. What I'm going to do is I'm going to take out that like a coefficient. It'll make life easier. All right. So you have the 1/3, and then the derivative of that is just going to be negative 80x to the third. So then your final answer, the second derivative, is going to be this, negative 80x to the third over 3. I just treated that 3 on the bottom as a coefficient, pull it out. Because there's no algebraic piece there, I did not need the quotient rule when I took his derivative. So no need to make things harder if I don't need to. All right, now let's move on. Check out another example. This one was nice and easy. I say nice and easy because, yeah, it's going to get ugly. But I digress. All right, so here we go. Let's start off. Take the first derivative. So you get 15x squared, and then you get plus 12y dy dx, and that equals 0. All right, get dy dx by itself, and when you do that, let's see, you would subtract the 15x squared and divide by the 12y. And just for fun, I'm going to simplify that there a little bit because I can see that a 3 will come out and will make my life easier. So there's the first derivative done. Now I've got an algebraic piece in the bottom. So when I go to take the second derivative, I definitely need a quotient rule. So, low d high minus high d low. A little implicit piece in there. Over low, low. So we have that. All right, so before I go any further, I'll give myself a little bit of room. I said a little bit of room. Thanks for working with me, program. Okay, there we go. I'm fine. I'm calm. Let's clean it up a little bit. We have negative 40xy. Then we're going to have plus 20x squared. And then we have this dy dx. We'll come back to him. Over 16y squared. And you're like, oh, that's not all that bad. Oh, you know what? I see a 4 divides out of everywhere too. So let's do that. Again, make life easier for us. Oh, actually, does better than 4 divide out? No, not better than 4. Okay, so I simplified the fraction. So I have negative 10xy plus 5x squared dy dx over 4y squared. Now, here's where the fun starts. You see that dy dx right here, that dy dx? We have to do something. Do you know what we have to do? we have to go up here. We have to take the dy dx from that we had in the first step, and we have to substitute that guy in there. So we're going to put negative 5x squared over 4y into his position. All right, so let's do that. So then the second derivative, this is still equal here. We have negative 10xy plus the 5x squared, and I've already forgotten what it is. Oh, it's negative 5x squared over 4y. And oh, look at that complex fraction. It's so good. All right. Well, before I get into fixing up that complex fraction here, let's go ahead and just do what we can in terms of simplifying. That's going to be minus 25x to the fourth, and technically he's over 4y. And then that's going to be over 4y squared. Now, there's nothing here that simplifies before I go to the next step. So remember, you multiply in order to clean up the complex fraction. You're going to multiply everything by 4y, the LCD of the entire complex fraction part. So when we do that, just multiply this guy by 4. When you multiply the next piece by 4, it just makes it go away. And then since I'm putting 4y downstairs, there we go. Multiply the 4 by 4 is 16. Y times y squared is y to the third. So the complex fraction, that is what's going to give most people algebraic hiccups. All right, let's try this again with another one. Just walk through the example. All right, first derivative first. That's where the implicit piece comes in. Solve for dy over dx. All right, so then you're going to have 8x divided by negative 2y, which then simplifies to 4x. Oh, we have a negative 2 over y. Okay, so there's your first derivative. Now let's go for the second. Looks like a quotient rule, and it is. Low. I'm going to consider, by the way, that negative sign. I'm going to lump him together with the 4x. So low d high minus high d low over low low. All right, let's clean it up a little bit. Negative 4y plus 4x dy over dx, and that guy's all over y squared. Alrighty, now we're going to go ahead and we're going to substitute that piece right in there. Babamo, let's do that. Give him a little bit more space. And so we have a negative 4y plus 4x. I've already forgotten what it is. Negative 4x over y over y squared. Okay, let's get together what we can before we need to figure out what we need to do with the complex fraction. And in this case, it looks like the only problem we have is we have this little y bugger that's down here. So we're going to multiply everybody through by the y. And how about them apples? All right. Let's look. Oh, trig. Yeah, boy. Here we go. I have a funny feeling this guy's going to be ugly. But you know how I feel about ugly things. Remind me of me. Let's move on. First derivative. The derivative of tangent is secant squared. Now we need dy over dx. And that equals 1. Okay, so now let's isolate dy over dx. So do a little bit of algebra. We have 1 minus 6x, and that's going to be divided by secant squared y. And oh man, this is not going to be fun. Well, maybe for you. I actually enjoy this. But then again, I do this for a living. Second derivative time. low. You know what? I've got an idea actually. No, I'm gonna take it back. We are gonna do this, but I'm gonna do a little work first because I don't like the quotient rule, and you are actually allowed to do things like this. Because think about trig functions is they could turn into other things. Like secant squared, when it's in the denominator, is like saying multiply by cosine squared. Now, why would I do such a thing? Why would I introduce this to you? Because the product rule is a heck of a lot easier to deal with than the quotient rule. And you will not have that complex fraction issue if you turn a quotient into a product rule. You can also do this with algebraic pieces by switching the power, if there is one, to be negative in the denominator. But in this case, we could just change secant into cosine squared, and boom, it's all good. All right, so I'm going to use the product rule here. And so we'll go 1 minus 6x. We'll leave him alone for the first go around. And now the derivative of 2 cosine y would be, now remember, it's going to be 2 cosine y, because you did the power rule. We have the chain rule here is the power first. And then now the derivative of cosine y is negative sine y. And then we need a dy dx because it's got the y bits. And then plus here, with the derivative of 1 minus 6x is just negative 6. And then we have cosine squared y. All right, so we can clean this up and know what else we could do is we could take this part right here and we can also throw him in right there. Okay, so let's go for it. Let me scroll down just a little bit, give myself some space. And so 1 minus 6x. Oh, that's going to make a negative 2. Okay, we're good. Let's bring that negative 2 all the way out. And we have the cosine y, the sine y. And where's that? It's 1 minus 6x cosine squared. So, all right, we're definitely going to deal with that. We can collapse some things here on this side. Then we have minus 6 cosine squared y. All right, so, we're just having algebra fun now. We have negative 2. We've got 1 minus 6x quantity squared. And cosine cubed y, check that out, because cosine times cosine squared is cosine cubed. All right, then we have the sine y, and then we have the minus 6 cosine squared y. A lot of this heavy lifting here in this question was algebra, not even the calculus part. Keep that in mind that I'm going to say this over and over, especially if we continue on our journey together next year, is that the biggest problem people have in calc is not the calc part, is the algebra after you've done the calc part. So if you stink at algebra, you might want to rethink your choices in life. Let's do this one just for fun. So we've got a product rule to lead off, xy cubed. So we're going to go x times 3y squared plus, so I'm finding this first derivative, by the way. Look at that. Look at that. Got ahead of myself there. I need the dy dx here because I took the derivative of the y part. Now the product rule, the derivative of x is 1, y cubed, no derivative of the y part, no dy dx, plus 1 equals 0. Let's get dy dx by itself. So dy dx, I'm pretty good at algebra, so I'd be subtracting the y cubed and the 1, and I'd be dividing by 3xy squared. Oh, this one's going to be fun. This one's going to be fun because our quotient rule is going to be ugly. All right, so let's go for that quotient rule. Let's go for that second derivative. And give myself a little bit more space here. Definitely going to be needing more. So we have low, d high. Now the derivative of this is just going to be negative 3y squared dy dx. Okay, all right. Minus high, d low. Now down here, it's a product rule within the quotient rule. Man, this is fun. So we have 3x times 2y dy dx plus 3y squared. Okay, and that's all over. Still got the quotient rule. The low, so that's going to be 9x squared y to the fourth when you square that guy out. Oh, man. All right, so let's see. What have I got going on here? Do I have stuff that's going to make my life a little bit easier? Okay, this is going to look a little bit uglier in the beginning stages of cleaning this guy up. But when we start substituting and multiplying things, it's actually going to clean up. Not all that bad. But before, I got to make it, like I said, I got to make it a little uglier first. So it's going to be negative 9xy to the fourth, and then the dy dx. Just multiply those first two pieces together. Then I'm going to keep that minus sign for now. And for now, I'm also going to do this negative 1 minus y cubed. And let's go for in here. We have 6xy. Well, that's not a 6. I don't know what that is. 6xy dy dx plus 3y squared. 9x squared y to the fourth. All right, so time to substitute in for those dy dx's. Now recall, it's this part right here, the negative 1 minus y cubed over 3xy squared, and I'm going to forget it, so I'm going to scroll back up probably in about 30 seconds when I'm... Okay, I've already forgotten it. So, oh, wait. Why am I doing that? Need a bigger parenthesis. Oh my gosh, that looks terrible. And I said, okay, that's good. And what was that denominator? 3xy squared again. Well, some of you might already see what's going to happen. Oh, some goodness right there. It's going to make life a little easier. All right, let's simplify. Let's say here. In this first piece right here, when you got things, let's say like the x's cancel, y squared into y to the fourth, the 3 into the negative 9. So you have negative 3y squared, and that's going to be times negative 1 minus y cubed. All right, we're going to leave him alone. I'm not even going to deal with him. Minus, now let's look over here. I'm going to leave him alone too in the beginning. Negative 1 minus y cubed. And let's see what happens here. Now again, we've got some multiplying here through. We've the 3 into the 6 is going to give us a 2. The x's are going to cancel. Ooh, we have a leftover y downstairs. All right, so let's make that 2 over y like that. And then we also have that other part. All right, plus 3y squared. So, nope, let's not forget about the denominator. 9x squared over y to the fourth. All right, now the good news is we only have one part right here that's giving us problems with complex fraction. So if you're not paying attention here, the pieces of this are, this first piece here and this piece here. Now this piece is a little bit uglier. You got some ugliness going on there. So what you can do is distribute this parenthesis to this piece and this piece. Think distribution. When you do it to the first piece, this just becomes squared there, so that's kind of nice. When you do it to this piece, you just write it next to that. All right, and then you got to multiply everybody by this extra y. So I'm going to show you those in 2 steps. So the first part's not going to change at all. The second part, I'll do that distribution. I'll pull that 2 over y out in front. So I'll have negative y minus y to the third squared, and then plus, actually, technically, that's going to be a minus. Okay. Hello. Hey, how you doing? Oh, there it is. It came back. And what? So I'm multiplying that by that, and you don't have the 2 with that. So you have minus 3y squared and then a negative 1. Okay, then you have all this. All right. Oh, let's not forget about that denominator. Boop, 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 boop. Now, multiply everybody through by the y. Let's give myself some space because I keep crowding. Doing this in order to get rid of complex fractions. All right. Oh, wait a second. I just saw something. We got more to do. Do you see it? Check that out. We got like terms here. Well, let's get them together. Why have this thing be so darn ugly? All right. When you have negative 3 of them and another negative 3 of them, that means you got negative 6 of them. Got ahead of myself. All right, so let me just scroll up so I can see, make sure I copied everything down right. Okay, yeah. Alrighty, anything coming out? No, nothing really coming out, like the 9 and 6, but you can't do the 9 to the 2 then, so you can't do that kind of reducing of the fraction. All right, we're all good here. Take care of yourself, stay safe, brush hair, brush teeth. I don't know what else to say. Tea out.